Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Hello dear students, welcome back to our NEET live sessions. So Master NEET Crash program, we are going through a few modules we finished. Today in physics we are going to discuss about the chapter work, energy and power. Okay, let's go to the first question. Hope all of you are ready for the solutions. The first question, a rod of mass m and length L is made to stand at an angle of 60 degrees with the vertical. Potential energy of the rod in this position is. So we have to find the potential energy of the rod. We know that the potential energy equations, PE is equal to mgh, most basic equation of P. M is the mass, G is the acceleration due to gravity, h is the height of the center of mass from the ground. So mgh equation we can use it. So it will be like, so in this question is given from a vertical, a rod is kept like this way. Okay, it's making an angle of 60 degrees with this one. Mass of the rod is m and length is L actually. So L is there. So here we have to find at what height this center of mass will be. Let it be h, I am cutting. Now we have to find h, substitute here mgh, we'll get the answer. So here see, till the center of mass we have the length L by 2 is there. So if you just imagine a triangle here, so 60 degrees. Okay, if this h is also h only, so can you say what will be cos 60 degree here? Cos 60 will be adjacent by hypotenuse, is it? So h by L by 2 is there. We have to find h only. So h is equal to, that is 2h by L. So cos 60 degree is 1 by 2. So we have h is equal to 1 by 2 times L by 2, that is L by 4. Is it? So if you substitute it, it will become mg into L by 4. So see the answer? Yeah, mg into L by 4 we have the answer. So option 4 is the correct answer. Yes, great. Magastri Kavisha, yeah, got the correct answer. Good. So mgh equation only. So the center of mass at what height will be, that will be h you have to consider here. Okay, let's go for the next question. Power applied to a particle varies with the time as P is equal to 3t square plus 2t plus 1 watts, where T in seconds. Find the change in its kinetic energy between T is equal to 1 second and T is equal to 4 seconds. So power is given and duration of time also given. You have to find the energy. You know power equation for this one. Power P is equal to rate of change of energy with respect to time. dE by dt we can say. So that energy is here, kinetic energy. You have to find change in energy from 1 to t. So if you just rearrange this equation, dE will get P into dt, or the total energy will be integral P dt. Is it? You have to integrate this equation. So from where 1 second to 4 second is there. So 1 to 4 energy you have to find out. So if you integrate, E will be equal to integral 1 to 4. Power is 3t square minus 2t plus 1 dt. So if you integrate that one, you will get the answer as 3t square is 3 into t square is, you know, integral x raised to n, dx is x raised to n plus 1 by n plus 1 we have. So this will be 3 into t cube by 3, t raised to n is 2, 2 plus 1, 3 by 3, minus 2 into t raised to 2 by 2 plus 1 dt will become t. This one you have to integrate from limit 1 to 4. So if you substitute the values, we will get here. If you rearrange it, this 3 and 3 cancels, 2 and 2 cancels here. So it will be t cube. In t cube we have substitute 4 here. So 4 cube minus 2 square, that is 4 square plus 4 minus of t cube, that is 1 cube minus 1 square plus 1. So if you rearrange it for cube, we have 4 into 4 is 16 into 4, that is 64 minus 16 plus 4 minus 1 plus 1. Then here if you just rearrange it, minus will be minus 1 again, minus 1 plus 1 minus 1. So final answer will be 64 minus 16 plus 4 is there. So we have 68 minus 6, that is 62, minus 52 plus 1. We have the equation as 40. Will be, so (46) will be the answer, is it? Yeah, so yes, there. Kavi, you got the answer? Magistry, yes. Okay, so next concept you can do. If the linear momentum is increased by 20%, then kinetic energy will be increased by how much? The relation between kinetic energy and momentum we have to do. Is it? We have kinetic energy Ke is equal to momentum P square by 2m. Kinetic energy equation we have P square by 2m. So if you change it, momentum is increased by 20%. Then if any quantity is increased by this many percent, if you get it, then new momentum P dash will be 100 plus 20, that is 120 P by 100. We can put at 1.2 P will be the new momentum P dash. So here kinetic energy new Ke dash will be equal to P dash square, that is 1.2 P the whole square by 2m will be there. So this will be 1.2 square, that is 1.44 P by 2m. That is nothing but 1.44 Ke. So new kinetic energy is 1.44 times Ke. If you increase momentum by 20%, the new kinetic energy will be 1.44 times Ke. Then we have to find the percentage change actually. So percentage change will be delta Ke by Ke into 100%. That's the percentage change. Change by original into 100. So change will be 1.44 Ke minus the original one, Ke, divided by the original, Ke into 100. That is 1.44 minus 1, that is 0.44 by 100. So 0.44 into 100 we have, that is 44%. The answer will go to option number 1. So change in quantity, if anywhere question comes, many different chapters we have that concept. Change percentage change in length, so that what is the percentage change in resistance. Then Young's modulus, many where it comes. So wherever percentage change asked, then change by original value into 100. That ratio you have to do. Okay, hope you got it. Next question we can do. The area under the displacement force curve gives. Okay, a direct question. Force and displacement curve is there. If you find the area, will be a product of force into displacement. So here, if it is there, force F is there, displacement X is there. Suppose any graph, if you find the area below this, F into X will come. That is nothing but the total work done will be the answer. 3 will be the answer. Yeah, next week, correct? Kavisha, got it. So, total will be work done. Force into displacement. Okay, let's move to the next question. A spring constant 5 into 10 raised to 3 Newton per meter is stretched initially by 5 centimeter from the unstretched position. Then the work required to stretch it further by another 5 centimeter is. So one spring is there. Okay, from here, from 5 centimeter it is initially stretched. So from initial position it is stretched by 5 centimeter. Then again to stretch 5 centimeter, what is the work done? That's the question. Work done by spring force, W is equal to half into kxi square minus half into kxf square. Initial and final energies you have to find it. So total change in the displacement you have to find it, position. So we have the equation half into, the spring constant is given 5 into 10 raised to 3. So 5 times 10 raised to 3. Into the final position will be, see here, it is total stretched by 10 centimeter. Initially 5 centimeter. So total is 10 centimeter is stretched. So 10 into 10 raised to minus 2, the square. 10 centimeter square, that is xf square, minus xi square, initially is 5 centimeter, that is 5 into 10 raised to minus 2, the square. So if you solve it, it will be almost half into 5 into 10 raised to 3 into, see 10 into 10 raised to minus 1, that is 10 square. If you do it, so it will become totally, we have 0.1, that is 10 into 10 raised to minus 2, square is there. So 0.01 is there, 0.1 into square. Then minus of 5 into 10 to minus 2 there, the whole square we have to do. So it is 5 square is 25, so it will be 0.0025 if there. Is it? So 0.1 square, then subtract 5 into 10 to minus 2 the whole square. 0.05 the whole square, that is 0.0025. Okay, if you solve this one, you will get almost equal to 18.75 Newton meter. Okay, correct answer. Great. Let's go to the next question. A bomb of mass 30 kg at rest explodes into two pieces of masses 18 kg and 12 kg. The velocity of 18 kg mass is 6 meter per second. The kinetic energy of the other mass is, the kinetic energy of the other mass is asking. So we have the equation of conservation of linear momentum itself, you can use it. So m into u, initially body has the mass m and velocity u, just initially, that's rest only. Then m1 v1 plus m2 v2. After explosion it becomes two words. So here initially rest only, so it explodes at rest. So it's 0. So we have m1 v1 is equal to minus m2 v2. We have to find m1 is given 18 kilogram, so 18 into v1 is given 6 meter per second, 6 equal to negative of m2 is 12 kilogram, 12 into v2 we have to find out. Then half mv square we can find it. Is it? So v2 will be equal to 18 into 6 by negative 12, that is nothing but, if you cancel it, it will become 6 and 12 you to cut it, so it will be 9, minus 9 is there meter per second. So kinetic energy Ke is equal to half m2 v2 square, that is half into m2 is 12 kilogram into v2 is 9 square, that is 81. So 6 times 81 is there, so if you cancel it, 2 6 silver, 6 into 81. That will be 6 and 486 joules. Okay, yeah, correct answer. So it will be second answer. Okay, so just conservation of linear momentum concept is again apply there. Okay, next question let's do. A cyclist come to a skidding stop in 10 meters. So a skidding stop in 10 meters. During this process, the force on the cycle due to the road is 200 Newton and is directly opposed to the motion. The work done by the road on the cycle and work done by the cycle on the road is what? So one idea. So a skidding stop, a cycle is coming. The work done by the cycle on the road will be of course 0. Why? Road is not moving. You know work W is equal to F into displacement. Displacement of the object should be there on which the force is exerted. So cycle is applying a force on road but the road is not moving. So second part is 0 joule. Now first part what will be? We have W is equal to force into displacement. So we have force how much is applied? 200 Newton. And that is in opposite direction the displacement is there. How much it is? 10 meters. So minus 10 meter. That is negative 2000 joule will be the work done. 200 into 10 and that's negative. Then second part it is 0 joule of course. So the option goes to, yeah, the second one will be the option. Correct answer. Yeah, great. Correct answer. Kavi and Magasi. Okay, let's go to the next one. When a spring is stretched by a distance x, it exerts a force given by F is equal to minus 5x into 16x cube Newton. The work done when the spring is stretched from 0.1 meter to 0.2 meter is. So spring force, work done by spring force you have to do. Work done, spring force is a variable force, you know. So work done by variable force, we have the equation work is equal to integral xi to x of f of x dx. That's the equation for work done by variable force. So just substitute, everything is gone. You have to integrate that force from 0.1 to 0.2 meter. So it will be like equal to integral 0.1 meter to 0.2 meters. Then f of x is negative 5x minus 16x cube dx. So if you integrate that one, this will be, work will be, so minus 5x if you do, negative 5x square by 2 minus 16x cube is there. So 16x raised to 4 by 4. Then that you have to apply from the limit 0.1 to 0.2. That's it. So this will be equal to, if you upper limit and lower limit if you do, minus 5 by 2 into x square, that is 0.2 square minus 0.1 square minus of 16 by 4, that is 4 only. So you can cut short that one. That will be 4 times x raised to 4 is there, 0.2 times 4 minus 0.4 times, then 0.1 raised to 4. So if you solve it, you can have the answer. Work is equal to 0.2 square, that is minus 5 by 2 into 0.04. 0.2 square is there, 0.04 minus 0.01 square is there, that is 0.1 square, that is 0.01. That is minus 5 by 2 into 0.4. So it will become 0.04 minus 0.01. That is 0.03 only. So this will be almost minus of. Then the second part, 0.2 raised to 4 is there. So 0.2 into 2, that is 0.04 into 0.04 minus 0.1 raised to 4. So if you equate that one, it will be negative 4 times 0.2. The 4 times you have to multiply. 2 into 2, that is 4. 4 into 4, 16 is there. Then 4 decimals are there. 0.0016 minus of 0.1 raised to 4, that is 0.0001. So if you solve this answer, you will get as it is 8.7 into 10 to minus 1 joule. Is it? The options. Anugrah is there, yeah? Kavi? Yes. So minus 5 by 2. So this equation you have to use integral f of x dx. Okay. Wait, I'm sorry. 10 to minus 2 is coming. Oh, sorry. So it will be option 1 is coming. Is it? Yeah. 10 to minus 2 is sorry. 10 to minus not 1 minus 2. Fine. So next question let's do. An elevator can carry a maximum load of 1800 kilogram, maximum load including passenger plus elevator, is moving up with a constant speed of 2 meters per second. The frictional force opposing the motion is 4000 Newton. Friction force is given 4000 Newton. The minimum power delivered by the motor to the elevator in watts. So the movement velocity is given and force is given. You know, we have the equation power P is equal to force into velocity, F into V, or F dot V you can put it. Force into velocity can also be an equation for power. So what is the net force here and the V? You have to find it. So net force, while the elevator is moving up, then its total weight will be downward and also the friction force also downward will be there. So net force F will be here, mg, the total weight, plus the friction force Fs, I'm putting suppose. F. So it will be, total mass is 1800 into G is 10 plus F is how much? 4000. So this will be 18,000 plus 4000, that is 22,000. That much Newton is, sir. 20,000 Newton. Okay, so that is F. Then into V we have to do. So it will be, F is 22 into 10 raised to 3 into V is given 2 meters per second. 2. So this will be 22 into, that is 44 into 1000 raised to 3. That much watts will be. So 44,000 is there. So that is equal to right, kilowatts. Is it? So option is 1. Yeah, great. Hisham is the Kavi. Anugraha. Got it. Clear. Is it? So here power equation to force into velocity. That concept you have to use it. Force and velocity both are given. Okay, let's go for the next. A body moves from a position R1 is equal to 2I minus 3J minus 4K meter to a position R2 is equal to 3I minus 4J plus 5K. So two initial and final positions are given. Then under the force F is equal to 4I plus J plus 6K Newton. The work done by the force is, you know, a dot product, scalar product you do. Work done W is equal to, we have vector F dot vector S. That's work done. The same type of question you might have practiced in vector topic also. So F dot S, the scalar product you have to do. F is here 4I plus J plus 6K. That one dot. With the displacement you have to find out. Displacement is final position minus initial position. So 3I to minus 2I, that is I, minus 4J minus minus 3J, that is minus J, 5K minus minus 4K, that is 9K cap. You have to find the dot product. So this will be 4 times 1, that is 4, plus 1 times minus 1, that is minus 1, 6 times 9, that will be 54. So this will be 54 plus 4, that is 58, minus 1, that is 57 joule we have. Final answer. Yeah. Magas, you got it, Kavisha? Yes, great. So work done here, the dot product of force and displacement, we got F dot S. Okay, so this is the physics session here. Now you will have the chemistry session. Your teacher is waiting for you. See you next live session. Thank you for watching.
Hi dears, welcome back to Master NEET Chemistry Live DPP session. Yesterday we discussed some idea about thermodynamics. Today also we are going to discuss some more ideas about thermodynamics. Are you ready? So let's start with the first question, guys. Which of the following is an extensive property? Extensive property means they are actually depending on the amount of substance. That means whenever you are dividing a system into two, that property will change. Whenever you are dividing the system into two or three or parts, the properties are changing. They are called what? Extensive property. Whenever you are dividing a system into anything, I mean system, this is my system. If I am dividing it into two and the properties are not changing, that means they are not depending on the amount of substance, means they are called intensive property. So let's look about the first one, specific heat. What about specific heat, guys? Specific heat means what? Specific heat is actually defined for 1 kilogram. So it is the amount of heat energy required to rise 1 degree Celsius of 1 kilogram substance. For 1 kilogram it is defined. So it does not change with the amount of substance. That is already specific. So it is intensive. Heat capacity? Yes. That's our answer. Heat capacity is not mentioned. How much value we are taking, that is not mentioned. Heat capacity is actually the amount of heat energy required to rise 1 degree Celsius of a substance. Not 1 molar, not 1 kilogram. So that's why that's the answer. Here latent heat means that's for 1 kilogram. Molar heat capacity means for 1 mole. So if it is specific, if it is varying with only with the substance, then that is intensive. If they are varying with the amount of substance, that is extensive. Okay, guys? Okay. Ready? Yes, Kavyasha. Yes. Nice. Okay, we can move to the next question. This is the next question, guys. Once we are looking at the question, you can see there is H2O liquid is there. H2O liquid. This H2O liquid is in. H2O liquid is there. Its pressure is given 1 bar and 373 Kelvin. That one you are converting it into H2O gas. H2O gas. This H2O gas is 1 bar 373 Kelvin. So the temperature and pressure are same, but the state is changing. Here it is liquid, here it is gas. Now what about the question, guys? Look at the question. The correct set of thermodynamic parameters. They are asking about delta G and delta S. What about delta G? Delta G is while you are looking about the delta G, you can see here it is 1 bar 373 Kelvin, 1 bar 373 Kelvin. Pressure and temperature is not changing. So we can tell this is actually in equilibrium. So delta G equal to 0. Delta G equal to what? 0. What about delta S? Guys? Delta S, here it is liquid is changing to gas. State change is there. Liquid, they are somewhat loosely packed, but is gas, they are loosely packed. The molecules are in zigzag random motion in gas. So whenever liquid changes to gas, entropy, disorderness is increasing, it is positive. So delta G equal to 0, delta G equal to 0, delta S equal to positive. Option 1 is the correct answer. I hope all of you wrote it. Yes, Kavi. Anugraha Padmanabhan. Yes, correct. Yes, Magashri. Yes. Okay. Yes. So we can move to the next question, guys. Ready. So we can move to the next question. It's also same. So we can move to the next question. This is the question, guys. What about this question? CO gas plus half O2 gas. Okay, half O2 gas gives CO2 gas. Carbon monoxide, whenever it is reacting with oxygen, they are giving carbon dioxide. That's the reaction they give. Then they are asking which is at constant temperature and pressure, which is correct. Okay, so they given delta H, delta U relationship only. What's the equation between, what's the relationship between delta H and delta U? Yeah, delta H equal to delta U plus delta NGRT. Delta H equal to what? Delta U plus delta NGRT. So what's the delta NG? Number of moles of gaseous product. How many gaseous products are here, guys? How many gaseous product? Here one gaseous product are there. How many gaseous reactant? Here one, here half. So total 1.5. 1.5. That means 1.5. So what's the delta NG? Delta NG is number of moles of gaseous product, that is 1. Number of moles of gaseous reactant is 1.5. So that means 0.5. 0.5. That means 1 by 2. 1 by 2. Okay. So that's equal to delta U. Not 1 by 2. 1 minus 1.5 minus 0.5. Minus 1 by 2. Okay. So that means delta U minus this instead of delta NG I can write 1 by 2 RT. So delta U minus 1 by 2 RT. Is there any option like that? Yes. Option 3 is the correct one. I hope all of you got it. Ready? Yes, yes, Muhammad Isham. Yes, nice, 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 nice. That's the answer. Option 3 is the correct one. Okay. Got it, got it, got it. Nothing to think. Easy one, easy one, easy one. Okay. So we can move to the next question, guys. This is the next question. What about this question? The enthalpy of combustion at 25 degrees Celsius of hydrogen. Hydrogen's enthalpy of combustion is given. Hydrogen enthalpy of combustion is given. How much? Minus 241. Okay. And the enthalpy of combustion of cyclohexene, that is C6H10. That also given. How much? C6 cyclohexene is given minus 3800. Okay, and 3800. Then cyclohexane C6H12. Okay, C6H10. Then C6H12. Okay, C6H12. Also they given C6H10. Cyclohexene means that is actually C6H12. C6H10, correct. C6H10. This is C6H12. That is given minus 3920. Okay, minus 3920. Then they are asking the heat of hydrogenation of cyclohexene is. What is cyclohexene? This is cyclohexene. You know, this is cyclohexene. This is cyclohexene. Okay, this one, your hydrogenation means you have to add hydrogen. That time that will become cyclohexane. Okay, this is the reaction. So that means here we know that this is cyclohexene. Okay, cyclohexene means C6H10. That plus hydrogen, you will get what? C6H12. That's it. Its enthalpy only they are asking. Its enthalpy of reaction only they are asking. That enthalpy is called enthalpy of hydrogenation. Okay. Yes, Kavin Kumar. Dhoni on. Yes. Okay, nice. Okay. I don't know what is Dhoni. Okay, anyhow, this is delta HR0, C6H10 plus H2. That gives C6H12. Okay, C6H12. So this is the reaction. This is the reaction. Then for this enthalpy of reaction, that means enthalpy of hydrogenation is how much? That's the question. So they given, while you are looking the question, they given enthalpy of combustion of C6H10. This is the value. Enthalpy of combustion of C6H12. Enthalpy of combustion of hydrogen they given. If you know that idea means, then what we can do? If you know that idea means, we can write what? Enthalpy of reaction is equal to, listen to me very carefully, enthalpy of reaction is equal to sigma, enthalpy of combustions of reactants minus sigma, enthalpy of combustions of product. One formula is there. This formula we already learned. In the case of combustions, we can write means if they are giving combustions of reactants and products, we can use this one. We can apply this one. Enthalpy of combustions of reactants minus enthalpy of combustions of what? Products. Now let's check which all are the reactants here. Reactants is C6H10. Its enthalpy of combustion they given minus 3800. So we can substitute minus 3800. And the sum of enthalpy of combustion of reactants. All reactants enthalpy of combustion I have to add. Second reactant is hydrogen. Only one hydrogen is minus 241. So I am taking what? Minus 241. Then minus of enthalpy of combustion of product. Enthalpy of combustion of product, how much? The product is C6H12. That value is minus 3920. I am substituting minus 3920. Now you just add it. This is minus 3800, okay, and 241. While I am adding 1, 4, then this will be 1, 4. 4141 I will get 4141. 4141 minus 41414, then I'm sorry, 404041. Okay, 4041 plus 3920. That means plus 3920. This is minus. So that means 4041 minus 3920. That means this is 1, this is 2, 1. So that means minus 121 will be our answer. Minus 121. Is there any option? Yes. Option 1. Option 1 is the correct answer. Hope you all of you got it. Ready? Love from Tamil Nadu. Yes, Kavin Kumar. Great to see you. Great to see you again. Okay. Yes. Okay. So this is the one. This the one. So minus 121 is the answer. Okay. Ready, guys? Hope you got it. Yes. Yes, Magashi. Yes, Kavyasha. Yes, nice. Okay. So we can move to the next question, guys. We can move to the next question. This is the next question. Okay. This is the next question. Which of the following are not state function? This is our previous question. Okay. Easy question. Simple one. Which of the following are not state function? Actually, you have to remember only two path function. One is work, another is heat. Okay. What about this Q plus W? That is according to first law of thermodynamics, delta U equal to Q plus W. Internal energy is an state function which depends on initial state as well as final state, which depends on what? Initial as well as final state. So that's a state function. They are asking about not state function, so that's not the answer. What about Q? Q is of course, Q is what? It's a state function, it's a path function. It depends on the path followed. Work also path function. We know heat and work. Okay. Then again H minus Ts. Do you have doubt about H minus Ts? No. G equal to H minus Ts. So Gibbs free energy only, that H minus Ts. Gibbs free energy is a state function which depends only on initial and final state. They are not depending on the state followed, the path followed. So that also state function. So we have to find out not a state function means Q and W. Q and W means 2 and 3. Option 4 is the correct answer. Guys, ready? Yes, Mahakashri. Yes, Kavya Shah. Yes, nice. Okay, that's the answer. That's the spirit, guys. So, shall we go to the next question? Yes, we can move to the next question. This is the next question. In which of the following changes entropy decreases? Entropy decreases. What do you mean by entropy decreases? The disorderness is decreasing. In which case? We know that whenever disorderness is decreasing means that molecule should come closer. That molecule should come closer. If the molecules are moving far away from each other, it become more disordered. Okay. So while we are looking this one, dissolving sucrose in water. You are adding sucrose in water means they are actually going to ionize. They are actually become aqueous. That means their movement will increase. So their disorderness will increase. That is not the answer. What about the next one? Crystallization of sucrose from solution. So from the solution, okay, sucrose is crystallizing. It is coming back to solid state. So particles are coming closer. Entropy decreases. That's our answer. What about melting of ice? Ice is melting means solid become liquid. Entropy increases. Sublimation of camphor. Solid directly go to gaseous state. That time also entropy increases. Okay, ready, simple one. Yes, Ayush Dash. Yes, correct. Okay, so we can move to the next question, guys. This is the question. Which following reaction occurring in an automobile? This actually octane. Octane is petrol. Petrol undergo combustion and you are getting carbon dioxide and water and energy. The automobile vehicle will move. That only they are talking. Okay. So the sign of delta H, delta S and delta G would be. What's that? So while we are looking, this is combustion reaction. All combustion reactions are exothermic except nitrogen's combustion. Don't forget, nitrogen combustion is endothermic because whenever you are conducting the combustion of nitrogen, the nitrogen triple bond N triple bond N is there. So that reactions, nitrogen's reaction with oxygen is endothermic. We need to give more energy to break that nitrogen triple bond N. Okay, so that's the idea you have to, don't forget. That's idea you don't forget, okay. So all combustion reaction. Here oxygen is there, so all is a combustion reaction. All combustion reactions are exothermic except nitrogen's combustion, okay, don't forget. So we know that this is delta H equal to what then? Negative. Exothermic means what? Negative. Is it okay? Delta H is negative. Then they are asking delta S. What about delta S? Entropy change. You check here in the left hand side, 2 octane molecule is a gas and 25 oxygen, 25 plus 2, total 27 gaseous molecules are in left hand side. What about right hand side? 16 plus 18, 16 plus 18, that is 34 gaseous molecules are in right hand side, okay, 34 are there. So gaseous molecule is increasing, so delta S is positive. More the number of gaseous molecules, whenever increasing the number of gaseous molecules, what will happen? Entropy increases. So delta S is positive. So delta H is negative, delta S is positive. Then what about delta G, guys? What about delta G? We know that delta H equal to T, delta G equal to delta H minus T delta S. We know that we already find that delta H is negative, delta S is positive, then this delta G is always negative. It is a spontaneous reaction. It is a spontaneous reaction. That's the idea. So delta H is negative. They are asking about delta H, delta S, delta G symbol. So delta S is negative, delta S is positive, delta G is negative. Negative, positive, negative, negative, positive, negative. So option D is the correct answer. I hope you got it. Yes, Magashri. Yes. Yes, Shivam. Yes, correct. Okay. This is the one. Okay. So we can move to the next question. This is the question. Once we are reading this question, we can see the enthalpy and entropy change for the reaction. They given one reaction. Br2 liquid that reacting with the Cl2 gas, they are forming 2 BrCl. Okay. R 30 kilojoule. So delta H enthalpy change equal to 30 kilojoule per mole. And entropy change delta S equal to what? 105 joule Kelvin inverse mole inverse. One is in kilojoule, one is in joule. We have to convert it into joule. The first one I can convert it into joule. I am multiplying that. If I want to calculate kilojoule into joule, means I have to multiply it with 1000. 30 into 10 raised to 3. This much joule per mole. Okay. Now they are asking the temperature at which the reaction will be in equilibrium. We learned the idea, no need of derivation, I hope. Temperature is equal to directly, temperature at equilibrium, I can directly calculate delta H by delta S. Some of you may be thinking like that, how we got that equations are, you know that idea, and I am simply telling for those who don't know, okay. Delta G equal to delta H minus T delta S only. If it is at equilibrium, means delta G equal to 0. So that means delta H minus T delta S. Okay. So from that I can write T delta S equal to delta H. So T equal to what? Delta H by delta S. Okay. Those who don't know, this is the idea. From here only we are getting. So temperature equal to, whenever you are hearing about equilibrium temperature, if they are giving entropy change and enthalpy change, nothing, delta H by delta S. That's all. That's it. Do it fast. Okay. So delta H by delta S. What is delta H? 30 into 10 raised to 3 and divided by what's the value? 105. 30 divided by 100 means, if it is 300 divided by 100 means 3 into 10 square, 300. So it will be somewhat nearer to 300. The answer will be 285.7. I hope you will get. Yes or no? Yes or no? Yes, guys. So option 1 is the correct answer. Okay, option 1 is the correct answer. From here, one more idea you can see. Here delta H is positive, delta S is positive. So at equilibrium is this 285.7. So the reaction becomes spontaneous at a high temperature. That means above 285.7, the reaction will be spontaneous. Don't forget it. Okay. So we can move to the next question, guys. This question is which of the following pairs of a chemical reaction is certain to result a spontaneous? Which are the condition for spontaneous? We know delta H should be negative, delta S should be negative, then temperature should be negative, then that is spontaneous. Or else delta H is positive, delta S is positive, temperature should be very high, that time also spontaneous. Or else we learned the temperature independent condition also we learned. What's the condition? Delta H minus T delta S. This is equal to delta G. When this will be always spontaneous, this delta H should be, delta H value should be negative and this value should be positive. Delta S is positive means this delta G is always negative. It does not depend on the temperature, always negative. So what's the condition? Delta H is negative and delta S is positive. Delta H negative means exothermic, and delta S positive means entropy increases, disorderness increases. So exothermic and increasing disorder. This option, third option as well as fourth options are similar. I think some mistakes, okay, but anyhow here in the questions they both are similar, so we can choose either 3 or 4. Both are same only, so 3 or 4. Okay, ready, okay, yes, okay, ready guys, okay, so we can move to the that's all guys, that's the questions. So that's all about today's session. Actually biology session also today it won't be there because our health condition is not good, so that's why it won't be there. I hope you guys are watching, you are there in the comment box and you are coming and watching, you are utilizing this 1 hour session. While we are looking that comment session, we are feeling very much happy. So keep the same spirit up to the May 5. Don't forget, we have to achieve a very good rank in the NEET examination this year itself. We have to got an admission. Last day also I told we have to get an admission in the medical college, okay, in a very good medical college, okay. So hope you guys are doing hard work. So keep the spirit. We will meet in tomorrow's session. Thank you so much.